Welcome everyone to this next instalment of Prep Set Go as we continue our look at surface assessment and preparation. And as always, thanks for joining us. So today we'll be concentrating on a very specific element of the surface prep process and one that is of particular importance for the potential impact it can have on the flooring system or coating. And that topic is substrate moisture. And we'll be looking specifically at the following. So sources of moisture, the importance of testing, ramifications and effects of high moisture content on finishes, how to measure substrate moisture, and preventative measures and surface treatments. So substrate moisture, what is it? It's simply the amount of moisture contained within the substrate at any given time. And it's typically expressed in two ways, as relative humidity, expressed as a percentage, and this just represents the levels of water vapor in the substrate. And two, as moisture content, which is also expressed as a percentage and represents the amount of water in liquid form. Now there's also a third consideration, which is important when it comes to certain floor finishes, and that is water vapor transmission. And this represents the rate of which moisture vapor is expelled from the substrate. Now, let's look at the various moisture sources in a concrete substrate. Now, the most obvious is the initial amount of water in concrete, and concrete slabs need water for both the hydration process and for providing the necessary consistency to be applied and finished. Now, environmental considerations are things like rain, condensation, and dew on the surface. Could also be down to flooding. But then there's also active moisture, and this is often caused by missing, damaged or compromised moisture barriers under slabs, and this causes groundwater to permeate up, and it's also known as rising damp or negative hydrostatic moisture pressure. Now it's also important to note that concrete will never be completely dry, and the moisture content is prone to fluctuation based on a number of different factors, things like environmental, through rain, but also high ambient relative humidity as the slab draws in moisture and it raises the internal moisture content. Colder conditions, moisture is retained in the slab for a lot longer, and limited airflow, which means the slab will just stay wetter for longer. Now the importance of testing. Why is moisture testing of a substrate important before applying our coatings and floor finishes? Well, testing is important because there are certain tolerances products and systems can be exposed to before they have a detrimental effect. It's also important as it will determine the preparation required to make the substrate suitable for application. And there are a number of standards relating to different floor finishes and coatings that specify the maximum allowable moisture content in concrete that they can be applied to. So, AS 1884 for resilient flooring, for example, and AS 3740 for internal wet areas defines surfaces as damp when exceeding 80% relative humidity or when the vapor transmission rate exceeds 15 grams per metre squared over 24 hours. Now this translates to around 4.5 to 5% moisture content. AS 2455, on the other hand, for textile floor coverings, defines surfaces as being damp when exceeding 75% relative humidity or 70% relative humidity when measured on the actual surface. For each of these standards, testing of the substrate is mandatory before the finish or coating is applied, and each of these standards references the various test methods which we'll look into shortly. So what are the possible effects of excess substrate moisture on an overlaid coating or floor finish? Now, it could be delamination of the floor adhesive and then finish. It could be re-emulsification of the adhesive, and this is when the adhesive goes back into a liquid state. It could be swelling, lifting or warping and cracking of timber overlays, bubbling and blistering under vinyl finishes, condensation and mold and mildew development under carpet and vinyl finishes, bubbling and blistering and re-emulsification of waterproof coatings, as well as prolonged drying and curing of membranes and adhesives. Suffice to say, the effects of excessive moisture in a substrate on surface finishes are mostly detrimental and costly when considering the associated costs of replacement, removal and reinstallation. So how to measure substrate moisture? Now let's look into some ways that we can test the substrate moisture content. So ASTM F2170 is the destructive test method, and this involves coring holes deep into the depth of the concrete. Probes are then inserted and the relative humidity is measured with a thermohygrometer. Now this test is one of the most universally accepted and accurate methods for measuring moisture content. ASTM F2659 is a non-destructive method but this only reads about 20 to 30 mil of the concrete depth at the time of testing and doesn't provide an accurate or complete representation of the true moisture content in the slab. ASTM F1869 is a water vapor transmission test, and this test measures the rate of water vapor evaporation by using a desiccant, which absorbs moisture from the substrate and is then weighed over a certain period. And then there's the basic rudimentary test. So before the advent of fancy electronic testing, contractors would often duct tape a square piece of plastic onto the exposed concrete and leave it for a set period of time. And the amount of condensed moisture accumulated under the plastic will give a very basic reading of the estimated moisture content. Now, surface treatments. A simple and extremely effective way of dealing with the excessive substrate moisture is through the application of a moisture or vapor barrier. Now, these are surface treatments that have been around for a long time and have a proven track record in negating the destructive effects of excessive moisture. So RLA Moisture Seal is one such example, and it's a water-based 2-part liquid epoxy coating that cures to form a hard-wearing, high-bonding protective coating that is able to suppress active moisture whilst drastically lowering vapor transmission rates to acceptable levels. Applied in 1 to 2 coats to a surface, it can be finished directly over with a range of coatings, adhesives and finishes. So in summary, when it comes to surface moisture, there's a couple of simple things to remember before installing any coating or adhesive or finish. Now, number 1 is always read the TDS, the product TDS, to understand what the maximum allowable moisture content in a surface or substrate can safely be. Number 2, always refer to the appropriate governing standard to know what the recommended maximum allowable moisture content in the surface can be. Always test the surface for moisture, even if testing for the given application isn't mandatory. And number 4, make the use of vapor and moisture barriers standard practice to safeguard against any unnecessary issues. Well, that's it again for today. Thanks for tuning in, and we really hope to see you on the next exciting installment of Prep Set Go. Bye for now.